season starts here, the Vancouver Boat Show.
Welcome to the Vancouver International Boat Show virtual seminar series, sponsored by Freedom Marine International Yacht Sales, the premier choice for exploring the passion of yachting. If you have any technical difficulties, you can reach me, the online moderator, via the chat feature at the bottom of your screen. Questions for our speaker can be added in the Q&A box, also at the bottom of your screen, and questions will be answered after the slide presentation. It is our pleasure to present Review of Coastal Navigation with Dominique Prinet. Over to you, Dominique.
Thank you. Good afternoon. Welcome here to this presentation or this refresher on coastal navigation. I'm Dominique Prinet. If you're going to navigate, watch the kind of compass that you use. If you use like one like this one, you're not going to go anywhere. You're probably going to get lost. And be careful you don't go too far and too close to the edge. I got a fairly good experience in navigation. I used to be a commercial pilot in Europe and then in BC and in the Arctic and East and Northern, the high Arctic, flying with whatever I could because the maps at the time were very primitive and often wrong, and we couldn't use the magnetic compass because we're too close to the magnetic pole. And then for 15 years, I taught several courses in marine navigation, celestial navigation, and other courses to sailors in BC until a few years ago. So here is the plan for today. We're going to talk about how to determine a chart edition when you buy a secondhand chart. We're going to talk about the vertical datums, review the chart symbols. That's all stuff that you should know. So you're not going to learn anything new, but it's a review of what you should know. We're going to look at the aids to navigation, quick note on coordinates, measure of distances, measure of directions, lines of positions, and danger bearings. All stuff you should know without any hesitation. So how do you tell the age of the chart? On the Canadian charts, in the bottom left corner of the chart, the date of the edition is marked in print October 3rd, 1997. And then the adjustment, which are published in the notices to mariners, are added by hand with a stamp. So there is on this chart, there is an adjustment made in 1998 with this kind of ink and font, and there's another adjustment or two made in 1999 with this kind of font and ink, and another adjustment in 2001. And I remember when I was explaining that to students in the class a few years ago, there was a lady who jumped up and down in the room when one of my students, he said, I'm the one who puts the stamps. So in Vancouver, there's a real lady who puts the stamps on the charts. And if you buy a chart, look at the stamp, the latest stamp, to see how old your chart is. The horizontal now is standardized throughout the world, and it's called the WGS 84. So it's the World Geodesic Survey of 1984. And from that date on, all charts around the world are standardized, so the coordinates are the same, regardless of the manufacturer of the charts. And that's a new system, because until then, the horizontal datum was different for each country. So the coordinates were off. When you went from one chart to the other, the coordinates were different because their points of reference was different from one country to the next. So ever since the introduction of the GPS, it's been standardized, and now you no longer have to adjust your GPS. In the old days, if you didn't adjust your GPS to the horizontal datum of the chart you were using, you could be off by hundreds of meters and even 1 or 2 nautical miles in some cases. So now there's a standard reference for all GPSs and for all the charts. And if it's not WGS 84, check on the chart, then adjust your GPS accordingly. There's a list of datums to choose from in the menu. This comes from chart 1. Here is chart 1 here. And that's probably the most important image that you have to understand. So here's a cut of the water levels with tides. So the depth is measured from the chart datum here, and the chart datum in Canada has recently been redefined, and it's now the lowest normal tide. So that's really as low as the tide gets ever, except that once in every few years, there is an exceptional low tide, which brings the level a little bit below that. But normally, year after year, the lowest tide ever is at the chart data. So all the depths given here are minimum depths, whereas in the US, the reference is different. And sometimes the depth, the real depth, is less than what you see on the chart, and sometimes it's more. Now, this part here is always above the highest water. The high water level is the highest high water large tide. That means that's as high as the tide ever gets. Contrary to the lowest tide, which is not the lowest tide ever, it's the lowest normal tide. This is the largest, highest tide ever. So the land which is marked in yellow is land on which you can build a house. This is the clearance here, which is based on the highest water level. So the clearance shown on the Canadian chart is the minimum clearance you'll ever have, 9.2 meters above the highest tide ever. This rock is awash at the chart datum, and it's indicated with 4 dots. I'll ask you questions about that in a minute. This is a rock which is between the low tide and the high tide, and it covers and covers. So the green shows the weeds and barnacles, and that means that sometimes you see it, sometimes you don't. The 4 means it's 4 meters here above datum, and you know that because there is a line underneath the 4, which means datum. So it's 4 meters above datum, and the 4 means that the depth is not here, but it's where that image is. So the bracket means it's written here, but it applies somewhere else. The same thing with this one. This one is 4 meters above datum, and the 4 meters is not here, it's over there where the sign is. And the elevations are noted from the highest tide ever. So if you have a if you have a tower, for instance, or a lighthouse, and if you're at the distance at some intermediate tide, the height of the lighthouse is noted next to the lighthouse, and it's counted from the light itself to the highest tide. And if you're using a sextant to measure your distance, for instance, you're sailing here and you measure the distance or the angle between the light and the reference point here, you use the highest tide, which you can see by looking at the color of the rocks. If it's a lighter color, that means it's washed, and here it usually gets darker. So from the change of color here to the light, you measure the height, which is the one marked on the chart. Here it's 135 meters. That's the height from this to that tower up there. So a few chart symbols to refresh your memory. Anybody knows what that is? Those are little worlds. Now you know that, we just saw it. What's that? It's a rock at datum. Datum because it's got the four. So you never see it because at the lowest tide, then the water level is just at the top of the rock. So any tide will hide it. This rock is below datum, so it's always covered no matter what. But it's very close to datum. And it used to be between 0 and 2 meters below datum. Now the 2 meter limit is removed, and it's just a rock which is below datum, but close enough to the surface that it's a danger to navigation. I'm just quoting the official text here. It's a danger to navigation. So it's close to datum, but nobody knows exactly how deep it is, but watch for it. This one, you know that. It's an area which covers and uncovers because it's green. Sometimes you see it, sometimes you don't. And that little mud bump or earth bump or whatever it is 2 meters above datum, which means that the local tides are 2.9 meters or more because there are tides which cover it. And this is a rock. The 3 means it's 3 meters above datum, and the 3 meters is where the rock is marked. And then so 3 meters above datum, and that's an area also where the tide has to be 3 meters or more, because sometimes it covers and sometimes it doesn't. Now, what is this? WK, sounds like whiskey. So this is a wreck. 4.6, the highest point of the wreck is 4.6 meters below datum. And this, somebody mentioned, it sounds like the metro intake in Paris, the underground station. They're marked with an M exactly like this. Well, it's on the chart, it doesn't mean that there's an entrance for the metro. It means that it's a marina. Those are sector lights or ranges. Those lights you can line up to follow the true course 230 degrees to the southwest as you come in, and the direction out is also marked. It's 180 degrees more than that. And the first light is visible in this sector, and the second light is visible from that sector. And those lights are fixed and green. And the second light is taller than the first line. So when you come in within those sectors and try to line up the two lights here, you're coming in on a heading of 230 degrees true if they're lined up, and you can keep them lined up because the second one is taller, so you can see the two, one behind the other. Anybody knows what the A is here? This is active pass. What is the mystery? The A is an indication that the currents in the pass are in the Canadian Tide and Currents table. It's a book which gives you for the year, every hour on the hour and every day, the currents, or it tells you the peak currents, the flow and the ebb and the turns for every day of the year in the Tide and Currents table. That's what it means. So if you go through active pass, look at the tables to find out the currents. Here is a current. Anybody knows what the barbs mean in the back? That's on the chart, and it's a maximum current. It's a maximum flood current because it's got the barbs here. Those are compulsory reporting points. If you're talking to radio control, you have to report on these points which are marked on the chart. This is a clearance from the power cable to the highest tide ever. So you always have 9.6 meters of clearance. What is this? This is an underwater cable, so don't drop your anchor there. And how about that one? A radar reflector. So on your radar screen, you will see large dots and dashes pointing towards the center of the reflector. A religious institution, usually a church, but not necessarily. Now, that's another document you should have. By the way, the chart one I just showed you with all these symbols is available off the web in PDF. And this Canadian Aids to Navigation System is also available for free. And PDF, you can get it on paper. I used to have, it's a centerfold. And so it's a double page, and I used to have it classified. And because it's a fabulous reference, you have the lighthouses, you have the lighted aids, which are on the ground, but with a light, and they're fairly rare. The ranges, the sector lights, and the standard day beacons planted on the ground. That's the ones that you see most of the time. For a port side or a port bifurcation, starboard side and the starboard bifurcation. And then the lateral buoys with the lights, the cardinal buoys and the special buoys within a harbor. Limiting the speed or anchoring or the depth or whatever it is. So be familiar with this and get it from the web or buy the book. Now we're going to look at the buoys. So it's based in Canada, and I have a problem with that, but that's the way it is. It's based on the direction of the flood current. Now, what is the flood current? Well, you sail up and down the coast, and you're sailing between two islands, and you don't know which way the flood current goes because your passage between two islands is east and west, and you have no idea whether the tide comes in from the right or from the left. So to me, it doesn't make any sense because you've got one panel which happens to be green or red somewhere in the channel, and if you don't know the flood current, then you don't know which way to go. So why bother putting a panel there? And in addition, sometimes it's based on the real flood current, and sometimes it's based on a theoretical flood current, which is assumed to go clockwise around Canada. So for instance, north of Campbell River on Vancouver Island, the flood goes in from the north to the south. That's a real flood, but the signs are set up on the general theoretical flood going from south to north. How the hell can you tell? But close to harbors or outlets, then it's a real flood that counts. And under a real flood or the theoretical flood, depending on how Transport Canada feels when they set up the panels, then you keep the red on your right, red right returning. When you return to the harbor, you go up a river, red to the right. A better way, which is widely used in Europe, and that's the only way it's used in Europe, is to have cardinal buoys, which tell you to stay north of this one, you stay east of this one, you stay south of that one, and you stay. Now, anybody on the water should know the difference between north, east, south, and west. So with a cardinal buoy, you know exactly where to go. It's very clear. So here's one example. That's a north cardinal. It's pointing up, 2 arrows pointing north. The way it's indicated on the poles in the water, on the spars or on the buoys, is to have a yellow base. And the yellow base here means a flat area like a sand beach. So yellow means sand beach, flat surface, and black means death. It's pointed, it's dangerous. So the top of the sign is marked in black. So from a distance, you can't tell what's on top here. You can't tell which way the arrows go. But from a distance, you can usually tell the color. And if it's yellow, the yellow is the base, the black is the top. So you have an arrow which points up. That means it's a north cardinal. And that's a north cardinal. So here's a north cardinal. You can see from a distance, you can't see the arrows, but you can see the yellow base and the black top. So it means an arrow pointing up. That's a north cardinal. I'll let you think about this one for a moment. The current flows this way from the land. It's the mouth of a river. It flows into the ocean. The north is up there. So which is the main course and which is the secondary route, and how you're going to navigate between those signs? Well, let's look at the first one. On this one, you can put in E on the left side, a Greek E, a left branch, a top branch, bottom branch, and horizontal branch. You can put a Greek E. So it's an east cardinal buoy, so you stay east of it. This one is a red right returning, you keep it to the right. This one is a green, you keep it to the left. This one is red, green, red. It's a bifurcation, but it's mostly red. There's red above and red below, so it's mostly red right returning, you keep it to the right. So you move this way. Green, you keep to the left and the right. So this is the main channel. This way, keep to the right. This one, you keep to the left, etc. This way. But when you get here, there's also a red. It's mostly there is some green, so you can keep it to the left and take this branch. So you can go this way. This you keep to the right. This you keep to the left. So this is the result, right? This is the main channel, and this is the secondary channel. Those are the coordinates. Watch, and I know from experience because I spent some years in East Africa, and I was sailing there and then occasionally coming back to Canada. On this part, the longitude increased to the right and the latitude increased to the bottom. And then this part is different. So when you read a chart, it's very easy to get confused. I know from experience. So here's how you read. First, you get the numbers. I often have students who forget to read the degrees, but read the degrees first and then look at the scale. It depends on the chart. So this is 2 minutes, this is 8 minutes. So if this 2 minutes, this is 1 minute. So 1, 2, 3, 4, 5. So this is 123 degrees, 0.5 minute west. This is 123 degrees and 1, 2, and 2 minutes. 0.3 for the last 20 years or so, the minutes have been divided into 10. They used to be in seconds, but now they're in tenths. So it's 123 degrees, 2 minutes, 0.3. And here, if it's to the right of 123 in this part of the world, then it's going to be 122 something. So 122 degrees and 58 minutes, 59 minutes, so 122.59. And the way to do it is to use parallel rulers, use the 15-inch ones, which are the ones long enough to take you from the center of the chart to the edge. The 12-inch ones are not useful. And if you have a point here, if you want to measure the longitude of this black point here, you put the parallel rules vertically on the chart and read the longitude up here on the top. And for the latitude, you take a divider and measure this distance, again, on your vertical rulers. And here's the measure to the nearest line. And you check it out on the left. And so you have to look at the degrees, 49 degrees. This is 10, 12, 14. So 49 degrees and 14 minute 0.9. That's your latitude. Okay, you don't use the parallel rulers for the latitude because you can't reach the edge of the chart. Measuring angles, you can use parallel rulers. I've given up because you walk the parallel rulers across the chart table and you hit a fold or there's a breadcrumb underneath the chart and then your parallel rulers turn 90 degrees. It drives me nuts. So I've always been using, and I taught my students to use, a square protractor, which is what pilots use, and it's a lot easier. And so if you want to plot a bearing of 25 degrees, you look for 25 degrees on the edge of the scale and put it right onto your landmark. And this is a Point Roberts lighthouse. So you put 25 degrees on it, and there's a hole in the middle. So with a mechanical pencil, you put a mark here, and you've got a mark here, and you draw the line, and here's your bearing. You don't have to walk anything across. And to measure a course, with the lines, you can easily line up your square protractor on a parallel or a meridian, and you just read the course one way or the other, and there's no risk of error. To measure short distances, you use dividers, and you measure the distance in nautical miles, and you remember that a minute of latitude and minute of latitude only doesn't work with the longitude. The minutes of latitude are nautical miles by definition of the nautical mile. So here, this distance equals to, if you start at 10, you've got 2, 4, 6. So it's 6, and this would be 7. So it's 6.8 nautical miles. The true north, the direction of the geographic pole. The magnetic north is a little bit different. Here is the magnetic north, here's the true north. And when I was flying in this area, that was in the late 60s, the magnetic north was here. When I think it was John Ross around 1840, I think, or 1835, looked for the magnetic North Pole, was here. So this is 1840, 1960. I forget where Resolute Bay is. I don't know if it's here or there. 1960 and 2015, it's up there. So this is why it's called variation, because the magnetic north varies from year to year. And the variation is east on the west side of Canada, and the variation is west on the east side of Canada. So here's how it's represented on the chart. The chart, you have two compass roses, but don't use the magnetic rose. Please use the true north. The true north is the outer one. If you have a course in that direction, you measure the true north on the outer scale, and the magnetic north is here, 17 degrees. So if it's 77 degrees true, it's a smaller angle in magnetic degrees, so it's only 60 degrees magnetic. So here is your hand-bearing compass. Your reading, this would be 120, so that's 126 degrees magnetic here. Here is the compass deviation table, which shows because the compass is devious. So there's a compass deviation. You think you're going in a certain magnetic heading, but the compass being devious gives you a different heading. It's off by a few degrees. So here's a table that you should have around your compass, and it shows you the compass deviation depending on the orientation of the boat and the correction to make to get the compass heading. To go from true to compass, true is what you measure on the chart. Magnetic is the hand-bearing compass direction, but the compass is slightly off by a few degrees. From true to magnetic, you remove the east variation, east is least, you add the west variation, west is best to get the magnetic. And from left to right again, you remove the compass deviation if it's east, and you add it if it's west. So for the compass deviation, going from left to right, east is least and west is best. And that causes endless confusion with students, but they finally get it sometimes. So when you take sights, you take your sights at 90 degrees to get the best precision. If you take 3 sights, which is a lot safer, then you take them at about 120 degrees, so they're evenly spaced around you. So here is a sight on the lighthouse, 126 degrees, and then you convert it to true, and here is the lighthouse. You put, this one is 143 degrees, so you put 143 degrees true on the edge here. And at the center, you put a mark and then you draw the line. And here is your bearing. And you write it this way. You put the time above, and I always told my students to put what they read on the compass below, because if they make an error and they plot it wrong and put the wrong number on the plot, it looks good because the plot corresponds to the erroneous number that they've calculated. So it's safer to keep the original number you measure the direction in degrees magnetic. So you put what you measured, convert it and plot it in true. So the next guy can take over and say, well, this can't be right. If it was 124 degrees magnetic, it can't be that way. Here it's okay, but in other cases it's not. And you put an arrow the same way as for celestial navigation. Celestial navigation, you can't reach the end. You're aiming at the sun or the planet with some stars. So there is an arrow at each end. But on land, you don't put an arrow at that end because it would cover some marks. You only leave one arrow. So it looks funny because the arrow is pointing away, but you're really taking the sight on this line. So that's okay. That's a proper international way of doing it. The R on top, and some people put true, but I think it's safer to put magnetic. You put one or the other below. So when you have two lines of position, here's 10 o'clock, your first line of position, 10 o'clock, your second line of position, and that gives you a fix, and you mark it fixed. It's a regular fix at 10 o'clock. How you take your bearings? You can use a magnetic compass, but you can also use various landmarks or combinations of signs. This is a transit. This is an artificial transit. So when you line up those two markers here, you're on that course, which is plotted in true degrees on the chart. And this one is taken with a magnetic compass. So this is your fix at 10 o'clock. Or it can be a natural transit. There is one I often use with students on the islands. When you go by here, just off Sydney, I think it's somewhere around there. You have a bunch of islands, and you can, in a flash, you can see the ocean through it for a second. It's very narrow, and if you look at the chart, you can see exactly the line on which you are, and so you mark the time and you take another bearing on something else, and that's another way to get it. Now, often students tell me, well, I don't know, there's no landmark and I can't take a bearing. Well, if you look at the top of a mountain, if the top is marked on the chart, then you use it as a reference point to take a site on it, if you can see it on the chart, and take any other line. And in this case, for instance, out of Point Grey somewhere in the there's one landmark. So students say, I asked them, well, where are we? Take a site. Say, well, there's only one landmark I could use, and I don't know what else to take. Well, take the depth. So a site on the landmark and the depth will give you a point, a position. And this is my last chart. When you go in, for instance, to Silver Bay, be careful to put danger bearings, which limit the sector in which you should be traveling, whether you're coming in or going out. You should stay within the sector. And the way to do it is to have somebody on the bow if you're going in, or on the stern if you're going out, and keep a look at a marker here. And the best one would be this green sign here. And you keep it with the hand-bearing compass at an angle that you read on the magnetic compass between 261 and 271. So if you're around 268 or somewhere in there, you're safe. It doesn't matter whether you're coming in or going out or going across. The boat direction is totally irrelevant. You get one of your passengers to constantly monitor this sign with the compass and tell you at what bearing he or she sees the sign, and that will tell you whether you're coming or going, whether you're in that sector or not. This is where everybody piles up every summer, because at high tide, you're quite away from shore and people think it's safe. And usually they miss this one, but hit the rock, which is at datum. It's got 4 points right into it. And that's the end of my story. A 1 minute commercial. All this information is provided into 2 fabulous books that everybody should have. One is called Coastal Navigation for class and home study, and it's been tested with students for 15 years, and it's been done with them. It's 250 pages, and it's very detailed, takes you by the hand. It is in color, and you've got accompanying it the coastal navigation exercises. Now, once you've gone through that, you should continue. Here's the Celestial Navigation Manual, and here's the Celestial Navigation exercises. They're both designed to prepare you for the Sail Canada test. They're available from Amazon, Indigo, Barnes & Noble, the large retailers, and from the publisher, which is here in Victoria in the Friesen Press. Most people buy it either from Friesen Press or from Amazon. You have to order them because nobody will keep them in stock. Now, here is another fabulous book which just came out about 3 days ago. It's all my wild and wonderful stories about flying in the Arctic and the high Arctic. This is at latitude 80 in 50 below. The passengers were mad at me because it was so cold inside the cabin that their whiskey was frozen, so they couldn't drink. And that's at noon when the sun is highest. And in fact, it seems to be above the horizon, but in fact, it was mostly below the horizon. You can see it because of the refraction of the air at low level. Latitude 80, close to the North Pole, 80 below, 11 hours of flying without stopping the engine and refueling while the engine was running, all in the dark under the stars. It's just one story, but there's about 15 of them. So it's all very exciting. So I sort of let you know. And if you want to contact me, now that I'm retired, I'm fully available. So phone me or call me, and I'll be there to help you out. And I'm now open for questions. Any questions?
Okay, thank you, Dominic. Okay, a question here. Do you use, okay, these questions, if you have questions for Dominic, please add to the Q&A box, and we have a few minutes, we can take them. If there's something that you want to know, please add them now.
Or maybe they can turn on their mic. Oh, but you've turned all the mics off.
Yeah, actually, we do have one question here.
Oh, okay.
Do you, and this is from Mike Evans, do you use a laptop and chart plotter interfaced with GPS? Do you think they replace a sextant and site reduction tables?
Yeah, well, the answer is yes, I do. When I was with students, for a matter of safety, I always had a laptop, and I had a laptop attached not to a GPS, but to a GPS antenna, which is a tiny little bug that you can stick on the window or on the ceiling with a suction cup and with a wire. So you don't need the whole GPS, you just need the suction cup. And with a laptop and a GPS antenna, then you have the chart, you know where you are. And I kept that, but I didn't allow the students to use it. And it doesn't replace the sextant. The sextant is used in part as backup, but really the beauty of the section is because it's absolutely fascinating. The story behind it and the concept behind is just very clever. So you learn to use a sextant and you learn to use the site reduction table just for the joy of understanding how it works and for the intellectual pleasure of using it. In practice, only the fanatics use it. And I've got people every year who tell me that they've gone to Hawaii and they've tested the sextant, but it doesn't replace a GPS. Everybody travels with a GPS, a chart plotter, or a laptop, and that's the way to go. But people should learn. I had a presentation on the sextant yesterday. People should learn how to use a sextant because it's just very smart, very clever, and intellectually very pleasing. So one doesn't replace the other; they're complementary.
Okay. Another question from Martin. What should be the oldest vintage chart for BC Waters on board?
Oh, they haven't changed much. I don't know what the oldest could be, but they've been very good. I started sailing about maybe 20 years ago, and there's no new land has been discovered in the last 20 years. So if you have a 20-year-old chart, it's okay. The problem with the charts, which are too old, is that they don't show the aids to navigation, and they don't show the proper display of the lighthouses. And so it's technical information, but the land itself, the islands, the rocks, everything has been well documented for many years. So you can use an old chart. It's the technical information which is out of date.
Okay. Ian asks, will nautical charts become redundant in the near future?
I don't think so. They are compulsory in Canada as backup to a GPS, and Americans going to Alaska, for instance, have been obliged to buy the charts when they don't have the backup in case there is a toll failure. Now, this is changing, and recently Transport Canada has allowed some ships to have an electronic backup, provided it's totally separated from the main navigation system. So it has to be connected. It has to operate on a different computer or a different chart plotter connected to a different power source, a different battery. So if one breaks down, the other can take over, and that has become now acceptable. It's a new adjustment to the rules as of a few years ago. But on small boats, I would recommend keeping the charts, at least some charts covering the whole area. When I was flying in the Arctic, I had a suitcase full of charts because it's so vast. But I always had, in case I lose a chart, it falls off the airplane, flies off, I drop it on the lake somewhere on the river. I had a general chart of northern Canada, so at least I could find my way around if I was missing that chart. You should have at least a chart showing a good part of the coast and with enough details that you can find your way around.
Okay. Mike asks, we are planning to sail the Atlantic Circle, departing from Newfoundland. Do you have any advice regarding navigation?
The problem there is the currents and the weather. You have to look at the weather traditional patterns, look at the weather patterns on average in the North Atlantic, and you have to go, you have to choose your route depending on where the lows are when you go out and when you come back, you have to go down south enough to go around the highs. So look at the weather charts and determine your route, because there are two ways to go there. You can go quite high. Well, for instance, when you come back, you can go north through the Arctic or very high above the depressions. And when you go east, you can stay south of the depressions. So, and if you want to go, so east is okay, but when you want to come back, then you either go through the Arctic around the north of the lows, or you have to go south of the highs along the tropics. So that's my advice: is find out where the highs and the lows are and choose your route accordingly.
Okay. Question from Mike. Canada Hydro has stopped printing paper charts. Will some private firm fill that gap and provide paper charts, do you think?
Well, the paper charts are that's the Canadian Hydrographic Service. Are they not printing any charts on paper anymore? That's the charts, the navigation charts are printed by the Canadian Hydrographic Services. And as far as I know, they're still printing charts. So I don't understand the question. I don't know has stopped printing charts, but they're available as far as I know.
Okay. Glenn asks, how do you determine which is the main channel in the river example?
In the river, you have the same signage as the one I showed you. You have bifurcations, which tell you that you can either go left or go right. They're not really, it may not be bifurcation. There may be options on the river, but if there is a choice, there's an indication of a main channel on one side. For instance, if you go up the river, if the main channel is the one to the left, you keep the bifurcation sign to your right, which would be a red, green, red buoy. You can keep it to your right to keep you on the main channel on the river. And you can also use the right side of the river as you go upriver, but that's a secondary channel, which is not so deep and maybe narrower, so you got to really be careful. So it's marked the same way as a real bifurcation.
Okay. Doug asks, is GPS any less accurate in the far north due to satellite coverage? Do you have any concerns with the number of boats transiting the Northwest Passage?
That's a tough one, because when I was flying, the GPS hadn't even been invented. This is why I wrote those stories, because flying up there, especially in winter when everything is flat and frozen and covered in ice and snow, and the compass doesn't work, that was absolutely awful. I think the GPS coverage is standard around the Earth, and you can cross the Arctic and the Antarctic easily with a GPS, so the coverage is fine. And as far as the number of boats crossing the Northwest Passage, it's not so much the number of boats that worry me, it's the size of the boats now with changes in climate. More cargo ship go by, and I'm concerned, for instance, of the large tourist boats which come in, because the Arctic is very shallow and it's not fully mapped. So if you stray a little bit off the deepest channel, it's easy to hit a rock and the pollution would be atrocious. So it's the cargo ship, the resupply, and the passenger cruise ships, which really worry me. It's not so much the number, but it's the size of them, because I think the government should chart the Arctic waters. Otherwise we're going to have some horrible pollution disaster, because people are going to hit rocks and nobody knows the depths of the Arctic Ocean. It's not shown. You get the odd depths here and there, but it's very rare. So you just hope for the best. I know, because I've been on one of these tours, and the skipper was very concerned, because he only followed the route that he had followed before, and he knew it was deep and he would never deviate from that route. So he was very concerned about hitting the rock. So that's a concern. But GPS navigation, I think, is now a piece of cake anywhere in the Arctic or Antarctic.
Okay. Al asks, when was Canadian chart datum changed?
1984.
Walter asks, tides and currents are no longer printed. There is a plan to discontinue privatized CHS charts, but they haven't discontinued yet.
Okay, so that's what we were talking about a moment ago. So CHS chart, the Canadian Hydrographic Services, are still available and they're still being printed. And some of the manuals, for instance, I don't know whether chart 1 is still being printed or not, but all these documents are now available for free in PDF format. So you can download them for free. You can consult them from your computer, or download them and print whatever pages you want, and it's all free. And I think that's the case for chart 1 and other publications. Yes. Yeah, okay. They're all available on the web.
Okay. This will be our last question from Chuck. Why do you plot the magnetic fix without converting it?
I'm glad you raised the question. I do convert it. You cannot plot anything on the chart unless you convert it to true, and everything you draw on the chart is true. You can't do it any other way. So you have to convert it. My point is that once you've drawn the line after having done the conversion, it's safer to mark on this line the original number which you use for the line. In other words, your original measurement, and you measured it in degrees magnetic, so you record along the line your measurement in degree magnetic, but you have to do the conversion to plot it. And the idea of marking your original measurement on the bearing is that if your conversion is backwards, and instead of adding 18 degrees, you remove 80 degrees, so you're 40 degrees off. And so your number of true degrees is false and your drawing is false. So you make the drawing, but you put a false number next to it. So it looks okay, because the direction of the line and the number associated to it look okay. They correspond, and it sounds okay. So, but if you draw the line 40 degrees off because you'd make the error in conversion, and you put your magnetic bearing, you write down your magnetic bearing on it, the next guy will say, well, if that was the magnetic bearing measured, it can't be in that direction when you convert it to true. So the next guy has a chance to catch the error. So I think it's considerably safer. Otherwise, you make an error and you draw the wrong line and you put the wrong number on it. Nobody will ever know the difference. So I would recommend, I always insisted to my students that they mark down on the line, once they've plotted in true, made the conversion, plotted in true, they mark down their original measurement. I think it's safer.
Wonderful. Thank you, Dominic, for the presentation.
Thank you very much.
Okay.
Thank you, everybody, and happy travels, safe travel. Bye-bye.
Okay, and thank you for joining us today. We are interested in your feedback, either on this seminar or if you have ideas on topics that you would like us to cover in the future. Simply click on the Evaluate tab located just above the seminar description and complete the form. After the show, all attendees will also receive a post-show survey. Be sure to check out all of the features at the Vancouver International Boat Show Virtual. If you have a question, check out our info booth. So we'd like to thank our sponsor, Freedom Marine International Yacht Sales, and have a great rest of your time at the boat show. Thanks all.
Bye-bye. Thank you.
Oh yeah, the season starts.